Now let's come down here and talk about functions, exponential functions. Now you touched on exponential functions in SM2. And so using the natural base e, first of all, an exponential function was y is equal to b to the x, where b was a number not equal to 1. And these functions took on the shape like this or like this. Now, if the variable in the exponent, if the exponent variable was positive, you had growth. If it was negative, you had decay, which is why the graph would be like this. So the thing is, if we use e in place of b, so e to the x, this is still an exponential function because, again, e is a number not equal to 1. So, and we call these the natural base exponential function. So before, this is just an exponential function, but if b is equal to e, then it's the natural base exponential function. So here's the parent function right here. So if this value right here is greater than 0, and if the value here is also greater than 0, then the function is exponential growth. Exponential growth function. So again, that's like right here. Now, if a is greater than 0, but r is less than 0, or in this case, negative, right? That would mean to be negative. Here would be positive. Then you would have decay. So here is your growth, and here is your decay. So again, if the x is positive, it's growth. If the x is negative, it's decay. And if it's growth, then going left to right, the y values are increasing. But if it's exponential decay, going left to right, the y values are decreasing, hence decay and growth. So let's talk about how we can graph these natural base functions. So tell whether each function represents growth or decay, and then graph the function. So for a, is it growth or decay? So we have y is equal to 3 e to the x. Now, this is positive. This is positive, so I have growth. Okay? Now, with an exponential function, I'm going to draw my x-axis towards the bottom, and I'm just going to draw my y-axis down the middle. So let's analyze what happens here. Let's say we plug 0 into the x location. So if we make a table of x and y, and we plug 0 here, so I get 3 times e to the 0. Now, anything that is to the 0 power is 1. So this just becomes 3 times 1, which is equal to 3. So when x is 0, y is equal to 3. Now, that's something that we should recognize, is that if there aren't anything being added or subtracted here, so we don't have any sort of shifts, which we will talk about, I think next time, I think next week we'll talk about transformations. But if there are no shifts, that means this number right here will be your y-intercept. Because when x is 0, this becomes 1, and then you're just left with that number being multiplied by 1. So that's something that you should try, a pattern that you should recognize. So in any case, what we can do, let's plug in -1 and +1 into this function. We can do that into a calculator. Okay, so let's see. We had 3 second e raised to the, let's do -1 first. So we get 1.10. Or is it 1.01? 1.10. So when x is -1, you get somewhere like right there. Now let's try +1. So if we have 3 second e raised to the first power, we get 8.15. So should be like somewhere up there. So we know that this function will come up like this and shoot up like that, exponential growth. All right, now let's try and graph this function right here. First of all, is it exponential growth or decay? So because this is negative right here, this is going to be decay. So let's go ahead. Again, I'm going to draw my x-axis low, this down here. Now, again, we don't have any shifts, vertical or horizontal shifts. Nothing's being added or subtracted. So that means, again, if x is 0, this becomes 1, and I'm just left with e to the 0, and that's equal to 1. So this means, because there's no coefficient, the coefficient is just 1, so that means the y-intercept will just be 1. So let's go ahead and make our x and our y table here. So when x is 0, y is 1. Now let's try and plug in -1 and +1 into the function. So if we have e raised to the, so if I plug in -1, that would be positive. So that's just going to be 0.5 power. I get 1.64. Okay, now if I plug in +1, that's just still going to be negative. So that's going to be e raised to the -0.5. And I get 0.61. Now let's try doing -2. So if I do second e raised to the, let me see what it is, -0.5 times by -2. Enter, I get 2.718, which is just going to be e. So 2.7, so here, 1.6, I get 2. That should be about right here. And then 2.718. This one's about like right here. So in any case, we know the general shape and we know a couple of points, so we know that's just going to continue up like that. So it's decay because the y values left to right are decreasing. Okay. Now, if you want to define a process here, then you should know that if there are no vertical or horizontal shifts, the y-intercept is the coefficient. Okay. And then other than that, just make a table, plug in x values to get your output values. And then you can just plot some points. Okay.